In this video, we will go over another type of integral problem. This problem will involve using partial fractions, but instead we will use the Heaviside cover-up method. Now this method I would only recommend for denominator that is comprised of distinct linear factors. I would not recommend using this method for repeated or beyond linear factors, as you would need to do something special for that to work. And so this right here is the problem that we will solve together. And so with this method, like with the other partial fraction methods, we would say that is equal to a divided by x plus b divided by x plus 1 plus c divided by x plus 3. So each term, x, x plus 1, x plus 3. And now we need to solve for a, b, and c. Now the Heaviside method is going to be a bit different. And so we keep the numerator 12, and the denominator are the other terms besides the denominator for a. So a has an x. Instead, I will put x plus 1 and x plus 3. Now, the value of x that I will put is x is equal to 0, the value that makes the denominator 0. Now, for b, it's the same idea. The numerator is still 12, but the denominator would include x and x plus 3. I won't include x plus 1. However, the value of x would be -1 because I want to make this denominator 0. And so that would occur when x is equal to -1. And for c, what I do is same idea. 12 divided by not this term, but the other two terms, x and x plus 1. And then I need to think, how can I make the denominator 0? And that's going to be x is equal to -3. And now we plug in the value. So x is equal to 0, put a 0 here, put a 0 here. We get 12 divided by 1 times 3, which is 4. So a is equal to 4. Now for b, I plug in x is equal to -1, and I would get 12 divided by -1 times 2. So -1 plus 3 is 2. And this would give us -6. And for this term, we do 12 divided by -3 times -2. And so we would get 12 divided by -3 times -2, which would give us 2. And so the next step is to swap. So a is 4, b is -6, and c is 2. And so we just swapped, and now it's very easy to take the integral for each of these three pieces. So we get the integral of 4 divided by x dx plus the integral of -6 divided by x plus 1 dx plus the integral of 2 divided by x plus 3 dx. And this is what we would get as our final answer. And that's all we need to do for this type of problem.